everybody, and thank you so much for joining me here at ContainerDays 2022 for my talk incorporating security into platform engineering, the do's and don'ts. My name is Anais Urlichs. I'm the open source developer advocate at Aqua Security. Before that, I was working as site reliability engineer. Now I also have a YouTube channel where I share tutorials from across the CNCF ecosystem and a weekly DevOps newsletter where I share just free online resources that I found useful from the previous week. Now, just to set the scene before we dive into the talk, what is platform engineering actually? Well, when you Google platform engineering, the first blog post that comes up is by Luca Galante, who is the community manager of a very large Slack and Meetup community around platform engineering. And they define platform engineering as follows. It is the discipline of designing and building toolchains and workflows that enable self-service capabilities for software engineering organizations in the cloud-native era. Basically, to summarize this, I'm not here to read any slides, but platform engineering is the idea that within the cloud-native space, you're empowered to deploy application features, bug fixes, and so on multiple times a day, on an hourly basis if you wish, or more often. And when you're developing this fast, this rapidly, you need to be able to also test and deploy your resources to staging environments, testing environments more often. So the idea behind platform engineering is that you have a platform. It could be an online platform, it could be a remote platform, it could be a tool that developers have locally on their machine where they can basically deploy and test their resources. And whether that's a front-end engineer or an infrastructure engineer, they should be able to go as high level or as low level as they need to deploy their resources and have them running and testing them out before they go to the official staging and production environment. Now, some platform engineering tools take it even further, that the entire workflow should be managed by engineers as well, from the development to actually the official production deployment. And the idea is you build it, you run it. And within platform engineering, obviously, when you follow that principle, you have to make sure that it's a fail-safe environment, right? That things that are broken can't be deployed to production. And we will get to that in more detail. But ultimately, throughout your entire life cycle of developing the resources, using resources, testing to deployment, you should be able to be empowered to not be able to depend on, to not have to depend on a central entity within your organization, to a central team or an individual to do the testing and deployment for you. So the thing is, when we now talk about security, and we don't often talk about security when you talk about empowering engineers and shifting left. So when we talk about security, and I mention security, the following things comes to people's minds. First thing is, people don't really know where to start and why to start. Then the other thing is, well, they might consider security, but it's often considered as the end of a sprint. It's not considered throughout the development process. Another thing here is, well, we do security testing, we do security scanning, but just not in my team. There's a team responsible for it. Or our tools are too complicated. Maybe people even have tools implemented, but they experience something called vulnerability fatigue, where they don't know what to do with all those vulnerabilities and security issues that they are shown from those tooling, right? So in the next few slides, I'm going to go over the why, when, who, what of implementing security tools into your platform engineering, then some of the available tools and the do's and don'ts. Our goal is ultimately to enable engineers to bring software into the hands of users faster. The thing is, when we do that throughout platform engineering with tools that empower engineers, we also have to talk about how can we do that securely, right? We don't want to end in a situation where people can just deploy whatever they think is working without considering the security part to it, right? And that's different to having a central team. If a central team has to do the deployment, you will have like a central point where people who are responsible for security can intervene and check that there are no critical vulnerabilities. Within platform engineering, you don't necessarily have that central point, which is the point of it, right? Which is the idea behind platform engineering. So, problem one, who's responsible when we implement security tools? Well, it always depends on multiple different factors, right? And a lot of times we don't even have one single person being responsible, which is an issue because then everybody is supposed to be kind of responsible, but nobody does anything really for that, right? So, first of all, it depends on the size of your team. If you're the only one working on a side project, you're going to be responsible for the security of the side project. However, if you're working in a large team, you will have different people who will have to contribute, right? Or you might have a specific person, a security professional who's responsible for it. Then the industry you're working in, is it a highly regulated industry or not? Do you have to show certain compliance standards? The type of technologies you're already working with. That's a big thing that I'm going to expand on in a second. And then also obviously company goals and leadership. Who's enforcing security standards or security best practices within your organization? Is it something wanted and enforced by providing budget or other resources such as time for learning from the managerial level or from the leadership level? Now, the next problem is, what tools should you use? I put together this overview of cloud-native security scanners, and I tried as hard as I could to get to the level of the CNCF landscape. It's not quite there yet, but as you can see, there are lots of different security scanners, and some of them, such as Clear, specialize in a specific type of security scanning. Others, such as Trivy, have multiple different implementations. You can use it in different ways. Then you have very specific ones for example, compliance scanning, such as KubeBench, KubeBeacon for CAS scanning, KubeScape Starboard for NSA scanning, right? So you really have to understand that there are multiple different security scanners. And if you choose one of them, it doesn't mean that it actually does what you need it to do, right? So you really have to make sure, what do you want to scan and why? The difference between the security scanners is the installation. How do you install it? Is it a CLI-based tool? Is it cloud native through Kubernetes CRDs, custom resource definition? Then when are CRDs being deployed? What type of custom resource definitions are being deployed? What kind of access do they have? You have to really understand that, because a lot of CLI tools, actually when you run the CLI command, install also resources within your cluster that you will have to clean up afterwards. So you want to understand, what is the tool actually doing? The scan coverage is another big part. Most security scanners pull from similar databases, but they will sometimes show you slightly different information. So you want to understand, where are the information coming from and what is displayed. Another big thing is integration, especially in open source tooling. You want to make sure that your tools have lots and lots of different integrations already available. More mature tools will have that, right? Built from either core maintainers or the community. And then lastly is the focus of the tooling. Is the tool focused on engineers? Is it focused on cluster admins? Who's actually using the tools, right? So this is how the different tools here will ultimately differ from each other, and you want to understand the details. Now, I just want to highlight Trivy. Trivy does a lot of different scanning, as you can see here. I'm not going to go into detail in each of them because this is not a presentation on Trivy, but ultimately, the thing is, how do you integrate it? Now, a lot of these security scanners actually have CI/CD pipelines integrations, or like steps provided on how you can easily integrate it into your CI/CD pipeline. And that's usually the first step of how would you integrate a security scanner into your workflow. But it's not the only place where you can do security scanning and be really proactive with the security scanning. So when we think about our development lifecycle, from developing over testing to deployment, and then observing how our application is behaving, right? And then improving it, there are different resources that we will interact with. So for instance, when we develop the application, we will have to choose, for example, libraries, frameworks, container images, and other resources that we will be using. Now we can do active scanning of those resources, for example, through file system scanning on our local machine, through VS Code extensions that scan our file systems actively for vulnerabilities, for misconfiguration issues. Then the other thing is remote Git repository scanning. What are we actually using in the first place? What issues should we be aware of before using those tools and resources? Then once we have developed the application and we want to package it up, we have to start the scanning of our Docker file, of our base container images. What are we actually packaging as part of our application to run it? And that's when we enter the misconfiguration section, I guess, where we have to do active scanning of all of our configuration files, such as also our infrastructure as code scanning, for example, Terraform, CloudFormation scanning, right? Those are all different kinds of scanning that we have to be aware of. And a lot of it will happen on the developer machine, right? For example, file system scanning can be done locally during development. Misconfiguration scan can be done by somebody else while they are configuring the Kubernetes manifest, the Terraform files, right? But ultimately, in addition to that, in addition to empowering engineers to do the part of scanning of the resources that they are responsible for, you can also do scanning within your CI/CD pipeline, like mentioned, right? To automate the processes. The thing here is to keep in mind that different to developing the application, to developing the deployment manifests, security scanning is not a must-have to deploy your application, to have a running application, right? Your application could be running perfectly, right, for the user, but have lots and lots of critical vulnerabilities. Actually, one of the main reasons why sensitive information from users is exposed are misconfiguration issues. And that ranges from healthcare data over dating app data and pictures and other things, right? That people share on the application just because somebody misconfigured their S3 bucket on AWS, right? Things like that will have a huge impact on ultimately the branding also of your business, right? Like if there are security issues like that, it doesn't look good. And at least if you have the security scanning in place, it doesn't prevent you from having misconfiguration issues, but it can help you to identify them much early on. And the thing is, when you automate security scanning as well and use the ICD pipeline, you want to make sure that the tools can scream at you when things are going wrong, right? That's another really critical important component to that, because otherwise people can just look away because they experience vulnerability fatigue and they don't have to fix it in order to run the application. And then the last thing is, once you're actually confident in deploying the application, the update, the feature, you want to have in-cluster scanning as well. There are lots of situations where people might modify resources by accident, might modify resources to test things, right? So you want to make sure that you know the health of the security of your cluster, of your workloads running within your cluster. So this leads us to the do's and don'ts of integrating security tools into your platform engineering. And it's building up of everything that I just said, ultimately. The first thing is utilize existing processes. Don't introduce new processes into your workflows. Like, don't have yet another tool that people have to use, right? If you're able to see security metrics within your reliability metrics, within Prometheus and Grafana, you're much more likely to look at it, to look at the dashboard, than if you have to look at an entirely different application, right? Then integrate with existing tools, like just mentioned. If you're using VS Code, make sure to use extensions, right? There are lots of different security scanners that have extensions that you can integrate into your existing developer processes, right? Also for cloud native development and infrastructure development, such as like defining your Terraform configurations, right? There you can have on-the-go active scanning of those resources. The next thing, like I just mentioned, make it visual. Don't make it something security scanning that people can ignore, right? Especially if you have a platform available for people to use, point out that people should take a look. It's their responsibility to take a look at the security scans, right? It's their responsibility to make sure that they are not introducing critical vulnerabilities that could expose user information into the update, right? And then the last thing is assign ownership. And that ties in again with shifting left. Shifting left, empowering engineers to do a lot of the testing and deployment by themselves is amazing. The thing is, if nobody is responsible for security, again, it's likely not going to happen. And you don't have to have a security professional who's managing that. In the previous startup I was working at, there was an intern who was integrating security tools into our workflows, into our existing tooling. And it worked great, right? They didn't make the core decisions, but it worked great to get started somewhere, right? And to have the tooling in place. Now, the don'ts. One thing is expanding too quickly. And there are organizations, for example, that went for Aqua Enterprise and then decided that that wasn't the right thing for them. They wanted to use Trivy instead, and Trivy was the right tool for them. And that's great, right? There are different use cases for each scenario. Like I mentioned, there's so many different factors, different things, that it all depends on which tool you want to choose. And ultimately, you want to make sure you start small, integrate security scanning in one part, and then expand from there, versus going all in into all different kinds of processes, integrating new workflows, defining new workflows, and integrating new tools and so on, right? Now, decoupled processes is another thing. Again, you want to have data that correlates. Right? You want to be able to correlate the data from, for example, if your application goes down, or if, you see one thing happen in your application, maybe that's correlated to more vulnerabilities being introduced, right? For instance, we had a lot of reliability issues at some point at the startup that I was working at, and that was because lots of crypto miners decided they want to use our free sign-up and credit options, right? And that ultimately slowed down the entire platform. Now, that obviously also ties into security of knowing what is deployed into your application, into your infrastructure. And that's a whole different story. There's another talk where we talked a little bit about that, which I can reference you if you're curious. Now, the last thing is, and like I mentioned again, don't make everything the engineer's responsibility. Because if it's not their core job, it's likely something else that's just on top of everything else they already have to do. Now, thank you so much for listening. I hope you enjoyed this talk. I'm going to be available now for questions. You can also always reach out on Twitter at Urlichs Anais. I hope you enjoy the rest of the conference and to see you around. Bye-bye. Thank you.
Nice. So it's time for a few Q&A. I don't know if somebody in the audience have any questions again. We won't bite. Trust me, we won't bite. Just raise your hand.
It's too early.
Yeah, perhaps. Yeah, perhaps. Need more coffee, perhaps, yeah? Yeah, more coffee, obviously. Okay.
We're also available at booth C8. So if you have any questions regarding Trivi, regarding our open source tools at Aqua or the platform, or you just want to say hi, yeah.
So you're here as well? No, kidding.
Yeah, we're here.
Anyway.
Well, no, I am not. I'm sadly not, but like the team is.
Sure.
Yeah.
I have one question for you. We have one question over there first.
Oh, exciting.
All right, cool. So you said don't make the engineers solely responsible. So any tips on who should the responsibility be landed on or shared between?
Totally. That highly depends again on the size of your team, on the expertise that you have again within the team. I wouldn't make it one person's responsibility, because then you're obviously having this one person as kind of the bottleneck if things go wrong. Now, if you have a team, I would again look at who's responsible for which resources already, who's managing the CI/CD pipelines already. Then that person would be more responsible on integrating security tooling, security scanning into the CI/CD pipeline, but might not be the person who's responsible in doing in-cluster scanning of the running workloads. So I wouldn't make it just like generally the engineer's responsibility of like you build the code. Obviously, like the resources that they're dealing with, they are responsible for the security of those resources. But in addition, beyond that, I don't think, from what I've heard and experienced working in startups, that it doesn't really translate into taking proactive actions to have better security scanning in place, for instance, and doing something about any potential security issues. So it kind of defaults a lot of time to when you say shifting left and empowering engineers to take care of the security tooling, that nobody will end up doing it proactively. And that's kind of where it goes. So it really depends again on what your team looks like and what kind of tools and resources you're already using. Again, like in the previous startup I was working at, we had an intern who was implementing the security tooling. And that person was responsible then ultimately to implement it, to set it up as like the first step. I hope that answers the question.
Thank you so much. We have one question saying, how can I integrate the tools, their reports, into Defect, Dojo, Jira, Nessus, Rapid7, blah, blah, blah?
So there are lots of different integrations. So for instance, with Trivi, you can use a tool that we have built called Posty that basically sends notifications to Slack, to Jira, to any notification site, any like page or like tool that you want to see the notifications at. Now, if security scanner such as Trivi is integrated into your CI/CD pipeline, then you will see the reports also within your CI/CD pipeline. Obviously, that's open source tools where you have to do a lot of manual setup with different integrations. If you want to have something more out of the box, then obviously an enterprise tool is more the way to go. But there are, while it's not like directly, for example, integrated within Trivi to send notifications to Slack, Jira, etc., your PRs, create PRs, there are other open source tools that will do that for you in combination with Trivi.
Thank you so much. I will add one question. We often speak about platform security, but how about the code itself? So the code of the app that we are deploying. What would be your advice or the tool that you know that could help developers to check their own code, making sure that there's no, vulnerabilities, of course, but issues or misbehaving, whatever?
Yeah, so in the case, I mean, depending on which languages, which tools you're using, you will use different, like for code testing, much more than like security scanner, because like security scanner, like Trivi, they will do the scanning right once you have kind of developed or like used already decided upon resources and used some resources. And I mean, with Trivi, you can do code scanning as well. So for example, your Go application for vulnerabilities, for misconfiguration issues, we have a VS Code extension as well that do continuous scanning while you develop the application as well. So those are options, definitely. But then again, it so much depends on which tools and like resources you're already using, which scanners you should then like kind of refer to.
Thank you. I think we're good for the questions. Again, thank you so much for your talk, and please give a big round of applause for Anna.
Thank you. Thank you. Bye-bye.
Thank you very much. Bye.